Parallel lines may seem boring, but they have their uses. One of their uses appears in the Triangle Proportionality Theorem, which uses a line constructed parallel to one side of a triangle to establish proportions for the other two sides. This video lesson will teach you to describe and apply the Triangle Proportionality Theorem, and apply the Triangle Proportionality Theorem to common situations encountered in daily life. Let's start. First, let's briefly cover parallel lines. Two lines are parallel if they do not intersect. Portions of those lines, such as rays and line segments, are also parallel. In the drawing below, line segment WO is parallel to line segment LF. What is the Triangle Proportionality Theorem? The Triangle Proportionality Theorem states that if you draw a line constructed parallel to one side of a triangle, it intersects the other two sides of the triangle and divides the remaining two sides proportionally. Let's break this down. Draw a triangle. Scalene, right, obtuse, it does not matter. With one side horizontal to you. Label your triangle SLI, with side LI at the bottom, horizontal to you. Side SL should be to your left and SI to your right. Construct a line parallel to LI anywhere you like so it cuts across the interior of the triangle. Where the parallel line crosses sides SL and SI, label those points C and E. Any way you slice it, triangle SCE and triangle SLI are proportional to each other. Also, side SL has been divided into two segments, SC and CL, that are proportional to the two segments side SI is divided into, SE and EI. The Triangle Proportionality Theorem is your assurance these conclusions are true. You can write ratios to show these proportions like this. Let's try an example. Here is triangle BOX. Construct a line parallel to the line segment and side OX. Where the parallel line crosses the sides BO and BX, label the points E and D. Write two proportions you know. Did you get two of these? Let's use the Triangle Proportionality Theorem in another example. You can use this theorem to find the unknown lengths of portions of the sides of triangles, if you know the other three portions. Suppose you are mapping out a delivery route, and you notice your 5 stops, ROUTE, make a large triangle. The highway department reports the road from O to U is closed due to bridge repairs. You know the road going from T to E is parallel to the OU road. You know the distance from your starting point, O to T, is 6 kilometers, and TR is 15 kilometers. You also know that the distance from stop R to E is 10 kilometers, but you have no idea how far you will drive from E to U. Thanks to the Triangle Proportionality Theorem, you can easily calculate it. Here's everything we know. OT to TR equals EU to ER. We can write this as a fractional proportions like this. 6 divided by 15 equals X divided by 10. All you have to do is solve the proportions. You can use cross-multiplying and division, or you can multiply both sides times 10 to isolate X. To cross-multiply and divide, we take 6 times 10 and divide by 15, which equals X. Or we can multiply both sides times 10 to isolate X, like this. 60 divided by 15 equals X. Simplified, X equals 4. The distance from E to U is 4 kilometers. Now let's imagine for a second you're a zookeeper with a crocodile problem. Your crocodile enclosure comprises 2 tall parallel walls, with the near wall 10 meters tall, but still shorter than the far wall. You know the distance from one wall to the other is 12 meters, so this gives your crocodiles lots of room. The weather is turning cold, so you plan to provide soothing overhead heat lamps for your crocodiles. You need to run aluminum tubes to support the lamps from the near short wall to the taller far wall. How long must the tubes be to reach across? If you cut them too short, they will drop into the enclosure. Construct an imaginary triangle out from the crocodile enclosure's near wall. Go out 24 meters and measure from the ground to the top of the near wall. Or better yet, use the Pythagorean theorem to calculate the hypotenuse of the right triangle without ever leaving your zookeeper office. The ratios are now clear. 12 divided by 24 equals x divided by 26. We can cross-multiply 12 times 26, which is 312, and then divide 312 by 24. So, how long must your aluminum lighting tubes be to safely span the crocodile enclosure? Did you get the right answer? They must be 13 meters long. Lesson summary. If you carefully read this lesson, studied the drawings, and watched the video, now you can describe and apply the Triangle Proportionality Theorem, which states that a line parallel to one side of a triangle intersects the other two sides of the triangle and divides the remaining two sides proportionally. You can use the Triangle Proportionality Theorem to find solutions to common situations encountered in daily life.